Okay, I'm heading to a ball game, and I know you want answers, so let's go ahead and talk about this. And I'm going to reset your temp and let you go back. But obviously, you got the first one right, and it is the most common math instructions, which are addition, subtraction, multiplication, and division. However, there are some others that are much more complex. There is no standard format used for PLC, which is number 2. You chose true. That is false. That's just kind of letting you know that you can look and see the different math instructions, and some of them have a source A, a source B, and a destination. Some of them have a whole lot more information, and some just simply have a source A and a destination. So the format is a little different for each one. That's all that's meaning. Probably read something into that, maybe a little more than what you thought. If you look at page 227 of your book, right in the middle of 11.1, between the word division and the word CPT in that paragraph, there is a thing that I've highlighted in the book on the shelf. Math instructions are all output instructions, so the right answer is outputs. Now, you have to be very particular about these, and you got this one right. What is the value of the number stored at N73? At source B, What is the value of the number stored at source B if N73 contains a value of 60 and N72 contains a value of 80? So if we had 60 in N73 and we got a value of 80 in N720, what would source B have to be? It'd have to be 20, because we have to add 20 to 60 to get 80. So up in here would be N73 would be 60, the result's 80. So that's 20. Same thing happened here, and you probably didn't notice this was subtraction. But notice this says add, this says subtract. So obviously, with reference here, if N73 contains 500 and we subtract 338 from it, we would not get 838, which is your answer. We would get 162, which is the difference between 500 after 338 is subtracted. So we've got this file here that if the rung becomes true, it asks what value will be stored in N710 when the rung comes true. Well, notice it's taking each one, it'll take them in order. 328, 150, 10, 32. Notice right here, this little gotcha expression is N11, which is what's down here, and then we're adding 10 to it. So it would be 338 simply because the very first thing that would happen would be we would add 328 plus 10. So this allows us to find a default value and add, or we could do all kind of different things there. But we could get the square, the diameter of a circle, circumference of a circle if we wanted to, or area of the circle, just as long as we put that formula there. But anyway, it's going to take them in order. It's going to, when this thing comes true the first time, it's going to take the 328 and add the 10. When it comes true again, it'll take the 150 and add the 10, and so forth. By the rinse repeat. Now notice this is square root. Now the name is square, SQR, but it is a square root, SQR, meaning the R meaning root. So if we have 4 and we're looking for the square root, we would get 2, which is the correct answer. If we squared 4, we would get 16, which is what you chose. So that's what got you there. Division here. We're asking if N73 has 40 and N74 has 3, what's going to be in N720? And remember, we can't store decimals, so basically 40 divided by 3 is 13. There is a remainder, but we can't carry that. The division doesn't have the ability to display anything but the full integers there. All right. Then the gate, I'm actually in the book, and I'm trying to look at this one, and you got the ClearWrite. Negate is not one that I use every day, and I'm going to actually pause the video so I don't take up too much of your time while I look at that one. Okay, what I'm reading in the book is that I should simply change the sign, which is what I thought. But obviously, if we change the sign of 2,345, it shouldn't be a positive 345. If anything, it should be a negative 2,345. So I'm going to look at that question and probably use the example in the book for this one to correct it. So I'm going to let you retake the test anyway, so you'll have the new question there. And it'll be a lot clearer than this one is, obviously, because it threw me as well. So that's the first one I'm not willing to argue with you about. And going to look at the clear as well. So once again, I'm going to pause the video because it's not one that I do every day. And obviously you got that one right, but I want to make sure why you got it right and you understand it as well. So stand by. Okay, so clear is exactly what it sounds like. I should have picked up on that, but didn't quite catch it. But if you look at page 234, left-hand side, it says the program of figure 1116 is an example of the clear instruction. The operation of the logic run can be summarized as follows. Upon execution, it sets all bits of a word to zero. So basically, it's just to clear out, nullify, take everything back to zero command. So that one's right, and that one's a lot easier than I potentially gave it credit for. So again, I'm going to look at number 9, change that one. Nobody else has taken this test yet but you. And I'm going to let you retake this, and if you have any questions, just see me before you do.